So everybody, if this is f prime of a, then let's see if you and I can't come up with both the function f and the value for a. Anybody? All right, how about this? Let me give myself some room. Number 69. Do you guys think possibly, I can do this? I agree, but since nobody responded, I'll put an extra step in. Do you think you can think of 1/2 as a sign of something? You trig experts?
Pi over 6.
Yeah, I agree, pi over 6. Do you think you can think of this as the limit? As h does a thing of f of a plus h minus f of a all over h. Then what's a? What's that? The sine function. It was just merely an interpretation of looking at the quotient as in terms of what a is and what f is.
I get
Oh
it.
shoot, you guys, we never answered the question. What is the answer? I said, what is the answer? I can repeat that a third time. Since the derivative of the sine function is a cosine function, and the derivative of sine of x is a cosine of x. But I'm going to take the derivative function and divide it by a, which is pi 6. Root
3 over
3 over
2.
Good. Civic root. And again, it was just a question of interpretation, nothing more. Stephen.
What, 35 to 45?
35 to 45.
35 and 45.
What section is it from?
3.4. I assume it asked to find the derivative. Oh, the second derivative. Oh. What do you think? Just use words. Tell me what to do. Tell me what to use. What tools? Product rule. Product rule says I got the first times the derivative of the second plus the second times the derivative of the first. I don't know. What do you guys think? Anything I can do to clean this mess up? I'm just being honest. Anything I can do to clean it up? Because I have to differentiate a second time.
Can you just turn them all into sines and cosines, see if anything cancels, and then...
If you insist. So I've got a 1 over cosine of x times of, I can't just write it as one factor. One term. Is a cosine tangent of x just this?
Yeah, except with a negative.
Yeah, I'll put the negative sign up front. I was just trying to write it as one term. And the cosecant can be interpreted this way. But that's merely a negative 1 over sine squared of x. Plus over here, 1 over sine of x times sine of x over cosine of x. There is a plus, yes. Times 1 over cosine of x. Does that help? Now what?
Oh, now you have to find the second derivative.
Okay, how do you do that? Always.
Well, why don't you just find a common denominator?
Y equals.
If it exists.
Is that what you would do? Find the common denominator?
No, I think I'm completely lost.
Yeah, you could,
Yeah, technically
you could
speaking-
do sine squared of x plus cosine squared of, or cosine squared of x plus sine squared of x all over sine squared of x, cosine squared of x. Well, oh, because there's a minus there. I was going to say you could just replace that with 1, but
Well,
you can't because,
Let's give it a shot. Can we just differentiate using the quotient?
yeah, sure.
You guys, yes or no? Can I not differentiate this with the quotient?
Well, of course you
Yes,
can.
you can.
The answer is no.
No?
What?
Because I don't know how to differentiate the composition of two functions.
Ooh.
Do you see my point? Well, whatever the chain rules, I haven't had it.
Can't you just use the fundamental theorem of J? Can you just say like sine squared x equals 1 minus cosine squared x?
That makes it even worse.
Really?
Because now I got a coefficient out from the composition of two functions upstairs. Namely a 2. Or Nabil, you could do this. You could use one of your double angle identities. Isn't the sine squared of x minus cosine squared of x nothing more than...
Please memorize.
Oh, sine squared, cosine 2 theta?
Blood's rushing out of my arm. What's another
Is
name
it
for the
sine
numerator?
2 of theta?
You guys, come on.
Cosine squared minus
Check it
sine
out, check it
squared.
out, hey.
You-
No, because you don't have a negative one out in front here.
Sine squared minus cosine squared is, I thought that was cosine 2 theta.
Well, no, negative cosine.
Oh, negative cosine of 2x.
That's what
All
I'm
right,
looking
yeah.
for. Shoot, I still think it's a mess. I got composition all over the place. I wouldn't go there. So, everybody, I'm stuck. Coming back up here, somebody give me another way to simplify this mess so I can differentiate more easily. I said, somebody come back up here and simplify so I can differentiate more easily.
Oh,
Yes.
wait.
Yes. I'll wait.
Oh, wait. Never mind.
I'm so excited.
I thought you could like do something before you even took the first derivative, and I got all excited, and I was like, nah.
Yeah, I guess you could rewrite in terms of sines and cosines, but it's not much easier. Well, I got an idea. How many terms do you have here? 2. Can you factor anything out? Is there anything common with factors? Yeah, a lot. I think y prime is a secant of x times a cosecant of x times nothing more than tangent of x minus cotangent of x. That's not that bad, is it? Now to differentiate a second time, would I not get them, I'm going to show my steps. Would I not merely get the first times the derivative with respect to x of the second?
Can you go back one step?
What's that?
How'd you get the secant of x, cosecant x?
Well, I was just looking at this term and this term, and I saw the secant of x in common as a factor, and I saw the cosecant of x in common as a factor, and so I pulled them both out.
Alright.
You sure you're okay with that? Yes. Okay, just tell me. Oh, sorry, I'm in the middle of product rule application. I guess if I add to this the second as is, times the derivative with respect to x of the first factor, which was this product. But that's merely going to give me the secant of x times the cosecant of x times homework last night?
Secant squared.
Secant squared of x.
Minus,
I can't hear you.
minus
I can't hear you.
Plus.
Yes, I agree. Plus the tangent of x minus the cotangent of x times yes or no, product rule? No, it's copying. We've already differentiated that product. It's sitting right up there. Actually, it's sitting right here. I think it's just the secant of x times the cosecant of x times the tangent of x minus the cotangent of x. Isn't that a piece of cake? Yes, I'll wait. You guys happy? Now you can blow up terms, collapsing, et cetera, et cetera, et cetera. I'll leave that for you. Your brain hurts. I'm sorry. It's not meant to.
Massager?
30, 45?
You guys, would that be really horrible to clean up?
Yeah.
Yeah.
See, I think emphatically no. I mean, I think if with these two groupings, one above this brace, one above this double underline, you can just factor out a
Secant.
secant of x, cosecant of x, and what's left over is this thing plus oh, look at that, a perfect binomial square. Expand, you're gonna get tangent squares, you're gonna get cotangent squares, which you can replace with secant squares and cosecant squares respectively with the second and third Pythagorean identities from trigonometry. Did you catch all that? Seriously? No, okay, wait a minute, I'm gonna do it then, I'm gonna do it if you don't mind, Nabil.
Oh, if you're gonna do it, then never mind my question.
Watch this. Do you guys agree that my doubly underlined thing and my brace thing are just two terms?
Yes.
Each of which has a common factor of this product. I'm going to pull it out. Unless you and I talk about what the heck remains standing as remaining factors. From the first grouping that's doubly underlined, wouldn't that just be this? I can't
Secant
read that
squared of
long.
x plus cosecant squared x.
However, from the second term on the right-hand side of the addition operation, is it not merely the case that this is what's left?
Yep.
Or shall I say, I've got a secant of x, cosecant of x times let's talk.
1.
Well, I think the first set of parentheses is superfluous. I'm merely left with a secant squared of x. Plus cosecant squared of x. And Nabil, unfortunately, I can't just proclaim as Western. It's definitely not 1.
Why not?
I think you're thinking of sine squared of x plus cosine squared of x is equal to 1. But reciprocating those two terms doesn't mean you get to reciprocate the third sine, unfortunately.
Well, if 1 is just 1 over 1, and secant squared of x is just 1 over cosine squared of x, cosecant squared of x is just 1 over sine squared x.
That's 1 over sine squared.
Nabil, do you see what happened? You know, when I combine these two fractions, I got a sine squared of x, cosine squared of x on the bottom. That's not equal to 1 necessarily. Unfortunately. It sure would make my life easier.
Okay.
Oh, you guys, sorry, I got stuck. I got an idea. Let's remove these parentheses. Would you not agree that an a minus b quantity squared is an a squared? Minus 2ab plus b squared. I know it looks bad. It's not bad. After all,
Wait, how'd you get 2?
Yeah, can you explain that?
well, twice the product of these two. These are both reciprocals, aren't they? Cotangent of x is 1 over tangent of x. So 2 times a times b would be 2 times tangent of x times the cotangent of x, but the tangent of x times the cotangent of x is... Oh, but I got the factor 2 out front, so I guess it's a 2. Are you there? Okay.
My brain.
Does this leave me with a secant of x? Cosecant of x? Do you guys see a secant squared of x minus 1 up here?
What?
Do you see a secant squared of x minus 1 in the parentheses? Yeah, I do, but secant squared of x minus 1 is just... Oh, there's another one. Do you see a cosecant squared of x minus 1 up here?
Yeah.
Yeah, you do, but that's nothing more than cotangent squared of x. Oh, there's another one. I'll combine them. I can even pull out a 2. You guys, that's not bad, is it? That's relatively pretty. I said, that's relatively pretty. Is anybody enjoying me?
Yeah.
Good. 2 people. right? You don't look very happy. That wasn't that bad, was it?
No. Good.
Yeah.
Like, how are you supposed to? Like, okay, so when you were like, when you made the second tan squared x and the second cotangent squared x, are we just supposed to like be able to look at that and just like know, like, oh, second and third fundamental theories? Yeah.
Unfortunately, yes. Because you're such experts at trigonometry. That's why you graduated trigonometry. What's that?
You didn't have the teacher we had, huh?
Happier? Seriously.
Crawl under a rock and die.
45, you're going to use, sorry, you might not have your book, sorry. Number 45, before you take a break. To
Yeah,
differentiate,
some of
we
those
use
like really killed me over the break. But I think I got that answer. Did you? Yeah. Yeah, I got that one.
the product rule. Use a product rule. Oh no, you're going to have to make a decision.
Weird watching other
Product of
people
what
do
two
it.
things? I got an idea. How about this first thing and the second thing? So I think y probably is the first as is times the derivative with respect to x at the second. Plus the second as is times the derivative of the first. It's just that. To differentiate, this thing is differentiate another product. Therefore, second application of the product rule. I've got the first times the derivative of the second plus the second times the derivative of the first plus sine of x cosine of x. If you want this to look pretty, you might want to rewrite this as x times the cosine of the
Square root of x? Or no, never mind.
So how long has it been since you took trigonometry? 2x plus sine of x cosine of x. Ah, shoot, it's still not pretty. This is the same thing as x cosine of 2x plus 1/2 of thank you. I use both the double angle identity for the cosine function and the double angle identity for the sine function. Did the author write his answer that way? Please say yes. I think so. Did you guys read take your 10? Oh, you're saying it dramatically. You're ready to run out of here. All right.
The author did get a different answer for the
What did he say?
first one you did there.
Oh, so this
35.
Right here?
For number 35.
Oh, what did he have?
2 times secant squared x tangent x plus cosecant squared x cotangent x. And
Can you say that again?
so 2 times the quantity, in
Oh, two times
parentheses,
quantity.
secant squared x tangent x plus cosecant squared x cotangent x.
I agree. You know, he did he converted the tangent squared to the secant squared of the parentheses. And he converted the cotangent squared to the cosecant squared using the same Pythagorean identity. He just swapped the functions.
Okay.
And that's equivalent. I agree. How about number 45?
Number 45 in the book.
Yeah,
Let's
what's the
see
same
here.
answer? I'm just curious.
X cosine 2x.
He's got
Yep,
the-
you got it. You got it.
Bottom line.
Yep,
I just
you're
didn't
right.
know what that
It's right.
But can you appreciate over here, you can use the Pythagorean identity in two different ways. I replace secant with tangent, secant squared with tangent squares. He replaced tangent squared with secant squares, that's where that comes from.
Okay.
Then he multiplied it.
So I mean, on a test, if we were to get like really close to the answer, I mean, and just not get maybe the exact same answer that you were
Well, if you
looking
got the
for. I
author's
mean,
answer to this sort of test question, when I'm at home, I'm well versed enough with trigonometry, I can see those things.
but I mean, say we got your answer and not the author's answer,
But I
would we
think
still
they're
get
both- I
you
think
know
they're both simplified, I would
both
simplify.
simplified? Okay.
I think they're points. Oh, I know they're points.
Cool.